The speed of an aircraft in still air is 200 kilometer per hour. This is the first vector. What do we know about this vector is we know the magnitude, but we're not sure about the direction. Let's proceed. The wind blows from west at a speed of 85 km per hour. Now for the second vector, we know about the magnitude as well as the direction. In which direction must the pilot steer the aircraft in order to fly due north? And for the third vector, we are for the third vector, we have to find the direction. We don't know the magnitude. They have not asked for the magnitude. For the third one, we need to find the direction. So how many vectors are there altogether? 3 vectors. For what vector the entire information is given? Entire information means magnitude as well as direction. Is it vector number 1? Is it vector number 2? Or is it vector number 3? And the answer is, it is the vector number 2. So we start off with this thing. We draw vector number 2 first. Wind blows from west at a speed of 85 km per hour. So wind blows from west means this is the direction of the wind, from west. So the vector would be pointing towards the east, because if the wind is flowing from the west, let's say, think about a fan, a very common fan. If the fan is blowing wind from the west, it means the wind itself is towards east. So I'm going to draw this vector over here. Yeah, I'll be needing this one. So this is the first vector, which is towards east, and the magnitude is 85.0. So the second vector, for which we know the direction, is the third one, which is also the resultant vector. How do we know this is the resultant vector? Because the aircraft has to steer. No, it has to fly towards north. Due north means it has to fly towards north. So whatever the direction of the wind is, whatever the direction or the speed of the aircraft is, and in whatever direction, the final velocity has to be towards north, which means the third one is the resultant vector. This is a very important step. So I'm going to draw the resultant vector. Now the thing is, the direction of the resultant vector is towards north. So I can draw the resultant vector over here. So this is your resultant vector, which is towards north. Let's label it R. And keep it in your mind, if you say this is your first vector, then we don't draw the resultant vector at the end of the first one. We don't do that. The resultant vector is not drawn at the end of the first one. Second vector is drawn at the end of the first one. So what is the rule? How do we memorize this thing? You can write over here. Draw resultant vector at the start of the first one. Start means tail, at the tail of the first one, not at the end. Keep it in your mind. At the start of the first one. Draw the resultant vector at the start of the first one. Why do we draw the resultant? Because only for the resultant vector we know the direction exactly. And for the first vector, we don't know the direction. Matter of fact, we need to find the direction of the first vector. Alright, up next, the second vector can be obtained by joining these two. And this one was 200 kilometer per hour. Now think about it. Try to check the triangle, vector triangle. First vector, then at the end of the first vector we draw the second vector, and the resultant vector is from start towards the end. Are we following this convention? Yes, we are. That means our triangle is accurate. So what do they ask in the question? In the question, they have asked us to find the direction of the aircraft, means the direction of the first vector, and with respect to north. If you check out all the options, we have to answer with respect to north. So if I can draw north here with this one, I mean, plenty of ways you can solve it mathematically. So I'm going to draw north over here. Say this is the north, and you have to find the direction of this one vector with north. So means you need to find this angle theta, and if this angle is theta, then this angle would also be theta, and this is a right angle triangle. You can use trigonometry here. What we can use is sine theta. Okay, so this is the angle theta, this one would be perpendicular, and this one would be hypotenuse. Sine theta equals to perpendicular over hypotenuse, which is theta equals to sine inverse 85 divided by 200 sine inverse of, and could you hit it on the calculator? Okay, 25.2 degrees. And what should be the direction of this one? Let me highlight it first. We need to find the direction of this one in terms of east, west, north, south. What is the direction of this one? Exactly west of north, because it's towards the left side. So west of north.